one more time. So absolute value function. Absolute value of x is defined as piecewise defined function. On each piece, it has a different definition. If x is positive, my y is x. If x is 0, my y is 0. And if x is a negative value, you have to have a negative sign in front of your x, where y is minus x. By definition of absolute value in physics is the absolute value of x is the distance between x and the origin, 0. So here you have the origin, you have some numbers, 1, 2, 3, 4, -1, -2, -3, -4, and so on. So if I ask you what is the absolute value of 1, you're going to say that by definition, it's the distance between 1 and 0. Distance between 1 and 0, which is obviously 1 unit. And it satisfies this definition. Since 1 is a positive number, the absolute value of 1 is equal to 1. What if I ask you to find the absolute value of -2? By definition, absolute value of -2 is the distance between -2 and 0. But what is the distance? The distance cannot be a negative number. 1 unit, 2 units, it's equal to 2. So take a look at the definition. X is -2. The absolute value must have a negative sign in front of -2. So it gives you a positive number as distance. That's why whenever you have a negative number, you must have a negative sign in front of your x, using the definition of absolute value. But let's talk about the symmetry of this function. F of x is equal to absolute value of x. How do you graph this function? To graph this function, you can use point plotting. Point plotting is just taking random values for x, plug that into function and find the y values. X and the y value, which is absolute value of x. If I plug in 0 for x, my y is absolute value of 0, which is 0. So 0 and 0 is on the graph. If I plug in 1, I get absolute value of 1, which is 1. I have 1 and 1 on the graph. If I plug in -1, I get absolute value of -1, or -1, which is 1. So -1 and 1 is also on the graph. Using the definition, x positive, I get my y equals to x. If x is negative, I get y equals to -x. It means that I have 2 pieces of lines. If x is positive, my y equals to x. X is positive, it means that I am on the right-hand side of x-axis. My y is x. If x is negative, if I am on the left-hand side of x-axis, my y is -x. Y equals to -x. So this function at 0 is equal to 0 has this behavior, V-shape. Absolute value of x has a V-shape graph. V-shape. So remember the definition of symmetry. Obviously, for any point like 1 and 1 on the graph, if I look at the reflection on the graph, -1 and 1 is also on the graph. If x and y is on the graph, minus x and y is also on the graph. So it's symmetric with respect to y-axis, and visually we can see the same. Symmetric with respect to y